Hello everyone, welcome back in my class of CIS 2168 Data Driven Design. We are now in part 3 of video lecture for statistical significance and we are in week number 6. In this part, that is in part number 3rd, we'll explore different statistical tests. So what we did in part 1 and 2 is summarized in the next slide. So aim is already explained, statistical significance and statistical test. We want to explore these two things in week number 6. And so far we completed objective 1, objective 2 and objective 3. This objective we completed in part 1 video lecture, and these two we completed in part 2 of video lecture of week 6. Now it's time to understand statistical test, because now you know what is null hypothesis, you know what is assumed hypothesis and how you will frame null hypothesis or assumed hypothesis, how you will analyze level of significance with the help of p-value. So you need all these things in order to perform a statistical test on your sample data. So first of all, I will explain different types of statistical tests. So all in all, statistical tests are classified in two categories. So first category is known as parametric statistical test and second one is non-parametric statistical test. And here you can see the examples of parametric and non-parametric tests are given. So this is Welsh t-test is the example for parametric test, whereas this test is known as chi-square or chi-square. S-Q-U-A-R-E. This is chi-square test. We read this term known as chi-square or chi-square. Some people call it chi-square, some call it chi-square. And Mann-Whitney U-test is also non-parametric test. So we'll discuss these tests one by one in the coming slides. So first of all, we'll see this one, that is Welsh t-test. It is a two sample test. So here you can see a two sample test that have acquired independently. So two samples, suppose you have sample A and sample B. These two samples have been drawn from population P and they have acquired independently. So there is no relation between sample A and sample B. So SA and SB, sample B, are not related. They are not related. That is why we call it acquired independently. So sample A is totally independent and sample B is also totally independent. So it is a two sample location test. We call it two sample location test, and it is based on the student t-test, t-distribution test. Same thing is given here, t-distribution, based on t-distribution test. And if you want to apply this test, then your data must be normally distributed. I already explained in week number 5 what is normal distribution of the data. So if your curve is of bell shaped, so you have data and your data is like this, like a bell shaped curve you are getting from your data, then your data is normal distributed data. So for example, if you want to apply Welsh t-test, so what you will do, suppose there are two methods, method M1 and method M2. You got some sample S1 from by applying method M1 or performing a task T. You are performing task T, and based on that you got sample S1. You got sample S2 from method M2 for performing any task T1 and T2. You got S2. So what you want to do, you want to check the performance of completing task T1 and T2, or performing task T1 by both methods are similar, or there is difference between the performance or between the performance of method M1 and method M2. So in the first sense, what you will do, you will say my H hypothesis, that is H0, means you will say there is no difference in the performance of method M1 and M2. So how we will say that? Mean value of method M1, mu represents mu value, mean value of method M1 is equal to mean value of method M2. It means that there is no difference in the performance of method M1 and method M2. So this will be your H0. If this is true, or it will be false. If this will be true, it means that there is no difference, significant difference in the performance of method M1 and M2. If this will be false, then what will happen? There is significant difference in the performance of method M1 and M2. It means that your assumed mean is true. That is, mean value of method M1 is not equal to mean value of M2. So you can test this hypothesis. If this will be false, it means that assumed hypothesis will be true. So this is how you will perform Welsh t-test. Now next I will explain chi-square test. So here you can see it is chi-square or chi-square test. Some people call it chi-square, some people call it chi-square test. So what will happen in this case? So what is chi-square test? It is a statistical hypothesis test. Statistical. So first point is, it is a statistical hypothesis test, and why we use it. Second point is, point number 2, it is used to perform when the test statistics is chi-square distributed under the H0. So what it will do, so first point is for chi-square test is, it is a statistical hypothesis test. It works based on the hypothesis. So what you have to do, if you are going to perform this type of test, this test, then you need to first form your hypothesis, null hypothesis and assumed hypothesis. And then what you will do, you will check your H0 is true or not for distribution under the H0. If this will be true, then you will say that the performance of method M1, M2, M3, M4, as many methods as you can take are same. If not, then you will say that there is difference in the performance of method M1, M2, M3 or Mn. When you are performing, so here you can see, are the two variables independent? So here two variables means, as I said, method M1 and method M2. So they are equal, or there is no similarity in the in method M1, M2. So it is not like you can just take two methods. You can take n number of methods. You can say M1, M2, M3, M4. Suppose you are dealing with four different variables or methods. So here this is first variable, this is second variable, this is third, this is fourth. So this one will be your H0. So you can say that there is no difference in the performance of all four methods. So you will check the distribution of the data for method M1, M2, M3 or M4, or for any variable. Like here you can see categorical data are given. So this is rain, dry, number of occurrence. These value indicates number of occurrence of the variable. So 14 times, 8 times, 5 times, 11 times. So high wind and rain 14 times, high wind and dry 8 times, low wind and rain 5 times, low wind and dry 11 times. So if you have this type of data, then you can apply chi-square test. So what you will do, you will first form the hypothesis, and then you will apply the formula for finding chi-square test, and then you can reach to a conclusion that H0 is true or it is false. If it is true, then there is no difference in the independent variable. If it is false, it means that there is difference in the independent variable. And what is the difference? You will see under assumed hypothesis. There are so I have covered two statistical tests. There are other most popular statistical tests are given, and I will just tell you the name: F test, pair t-test, ANOVA test. There is independent t-test, and there are two t-tests. One is independent t-test, another one is pair t-test. ANOVA test is also classified into two categories: one way ANOVA test and two-way ANOVA test. So what I want you to spend some time and on your own explore these tests. So this is the task for student. So I want you to spend some time and explore these tests. And if you want to get any answer from my side on these three tests, then please let me know. I will explain. So that's all from my side in this part. And now next I will explain what you will do in the tutorial session. Thank you very much.